Hi everyone. In here, I use brain tumor. I used to detect brain tumor by deep learning, and the dataset I choose is Kaggle dataset, and it's public review. And the structure of the dataset is divided into training and testing data. And here, the dataset path is counted from the drive. Then it contains 4 categories: melanoma, glioma, tumor, non-tumor, and pituitary tumor. And in this code, the the 4 categories are mentioned, and the number of images are represented. Then I done the pre-processing steps. First I checked the missing values and missing and corrupted images. Then I used in here there is no missing or character images. Then I used applied Clahe for MRI preprocessing, and in this the image is somewhat brighter, and it can the when we use for training, it will be easier to identify where the tumor is. And I saved that images in a different folder, and I used that folder to training the dataset. And here I provided the original and Clahe enhanced images to understand the differences. Then in the dataset, non-tumor class is somewhat lower, so I used separate data augmentation for the non-tumor class, so we can understand how to make everything same quantity of images. So then I use data augmentation for the training, for whole training, enhanced Clahe images. Then I split it into training and validation dataset. Then I use class weight for handling imbalance. Then this is what the deep learning model. I used MobileNet V2 as the deep learning model. I can compare different models such as CNN, FNBO, but comparing these, I prefer this one. This is more good, and it's a pre-trained model, CNN. So I use fine tuning for this, so it can be more accurate and give more precise values. And I use Adam as the optimizer, and the learning rate is 1e minus 4. I use less training rate, and I applied early stopping, model checkpoint, and reduce LLR plateau. I first train using 10 epochs by frozen the base. Then I fine tune top 50 layers of the base model. Then I again use low learning rate. Then I again use train with 20 epochs, and the accuracy then I save the model. Then I use to find the training accuracy and validation accuracy to compare the difference. Then I plot the accuracy over echoes and loss over echoes plot to understand the differences in there. Then I use the test data to test the model, and I found that the accuracy is 58, and it contains precision recall, F1 score, and support for the different classes, and the main accuracy, macro average, and weighted average. And also I have a confusion matrix. It shows the four classes in the true label and the predictor label. And then I use GradeCam for the visualization. uh, in here, one image from the dataset is taken and the GradeCam heat map is shown here. Then it's overlay on the original images, show that where the model is focusing, and it's correct in this. Then I use Gradio as the web application, uh, because it's easy to use, and I use in here we got an here we got an website link, but I use it's only for 1 week, so I use Hugging Face page to create it permanently, and the link is provided down here, and that's all.